welcome everyone. My name is Lucia. I am the acting executive director of DeepSense, and like I said, I am based in Halifax. And I just wanted to do a quick land acknowledgement and begin by acknowledging that we are currently in, and the data that we're all using in this challenge was collected across Turtle Island. We acknowledge the Indigenous peoples are the traditional guardians of this land and these waters that we call Canada, in which we gather here today. We acknowledge the historical oppression of lands, cultures, and the original peoples of this country, and know we have a role to play in the path to decolonization that we share together. We recognize our duty to fight for Indigenous rights to be restored and commit ourselves to the journey of healing. We thank more than 630 First Nations, their people, and ancestors who have taken care of these lands and these waters that we share. So thank you all for joining us tonight for the 7th annual Ocean of Data Challenge. We are excited to have everyone here. We are calling this one Coast to Coast to Coast because we have brought together a lot of different organizations, and it's our first national ones. Usually we keep them to Atlantic Canada, but because we are working with some national partners, we are excited to open this up for post-secondary students across Canada. And for tonight's agenda, I'm just going to do a quick brief review of tonight's agenda. So we're just going to do a quick introduction of everyone that is here and introduce the challenge. Then we're going to do a panel discussion with 3 speakers just to kind of give you an idea of what ocean data is, how we can use it, how people are currently using it, and maybe inspire something for your own challenge idea. There'll be a question and answer portion where you're welcome to drop any questions that you might have for our speakers. Afterwards, the speakers are welcome to leave. I forgot to mention that. You guys are welcome to leave after you're done the panel session. But we're going to stick around and review the challenge in more detail, review the data that we're going to be using through CIOOS, and we're also going to have to take any questions you might have. And then finally, because it's our first nationwide challenge, we're going to be doing a little networking event as well at the end. So let's give you opportunity if you're joining for the first time and you want to work on a team. This will give you an opportunity to maybe meet some folks and set up a team, but that will be at the very end. So hopefully you'll stick around and maybe meet someone new. So we'll do some quick round of introductions just so we know all the different organizations that came together to put this together for you. So like I said, I'm with DeepSense. We're based in Halifax, but we work with all of Atlantic Canada. And DeepSense is an organization that works with ocean companies, and we figure out what their data needs are, and then we set up projects to help do artificial intelligence and machine learning solutions. And then we actually hire students to do those projects at these companies. So we're helping the companies do some cool AI work, but we're also providing opportunities, paid internships for students to introduce them to the ocean field. Emily, would you like to go next?
Absolutely. Hi, everyone. It's great to be here. My name's Emily. I'm the manager of ShiftKey Labs. ShiftKey Labs is based out of the Faculty of Computer Science at Dalhousie University. We do a lot of extracurricular activities for tech students and people interested in tech, everything from hackathons to startup support. We've been working with ShiftKey for a year or two, with DeepSense for about a year on the Ocean of Data Challenge. So looking forward to kicking this 7th one off.
Awesome. Kat, want to go?
Yeah, great. Hi, everyone, and welcome from across Canada. This is exciting. So I'm the Education and Outreach Manager at COVE. We're located in Dartmouth, Nova Scotia, so pretty much just across the harbor from Halifax. And what we do is we're an innovation hub for marine technology companies. So there's about 65 companies located at COVE, all of which are developing new innovative ideas of trying to learn what's happening in our ocean and trying to manage our oceans better. So I work in the space of education, where we try to provide opportunities for students to learn about the ocean and get connected to it and learn about all the potential careers and opportunities available. So this is one program that we run with DeepSense and ShiftKey Labs regularly, but we also do internship programs in the summer, and we do in-class programs and some other challenges for post-secondary students, just like this. So yeah, that's just a little bit about COVE.
Awesome. Thanks, Kat. And then, I don't know, Ashutosh or Ilyas, whoever wants to talk Ocean Startup Project. We forgot to decide who that is.
I can do it. Well, I'll do it in both languages. So, I'm Ilias Lamorini. Je me présente, je m'appelle Ilias Lamorini. Je suis coordonnateur de programme pour le projet Startup des océans, the Ocean Star Project Coordinator. Nous accompagnons les entreprises en phase de démarrage et les startups dans le secteur maritime. So we support startups and early stage companies in the ocean sector. And if you want to connect, feel free to message me. I'll post my email address on the chat. Si vous voulez entrer en contact avec moi et si vous êtes au Québec, n'hésitez pas à m'écrire. Je vais poster mon courriel dans le chat. Merci beaucoup et bonne session à tous. Thank you very much.
Awesome, thank you. And then Shen, you want to talk DFO and CIOOS?
Hello, everybody. My name is Shen. I work for Fisheries and Oceans Canada, and I work on the Canadian Integrated Ocean Observing System, or CIOOS. And it is basically the bulk of all the data that you are going to be working with for this hackathon, so I'm really excited to tell you guys about it. Basically, CIOOS is an online platform for discovering and accessing all open source coastal and ocean data across Canada. So we work through all the sectors, all the regions to integrate all coastal and ocean data from all partners and try to make it more accessible and discoverable to basic ocean users.
Awesome, thanks so much. We all came together this past summer and started planning this hackathon or data challenge because I thought it would be a great way to use all this data. We always do our data challenges with open source data, and CIOOS is one of the biggest sources of open source data, which is amazing. And that's kind of the high level topic of everything is data. We have lots of different types of data out in our oceans. We're always collecting and keeping track of things. So it varies. As a company that works with artificial intelligence, we rely heavily on lots of data because you need a lot of data to be able to train your models to do whatever you want it to do the AI essentially. And so data is at the core of everything. And so there's a big movement happening right now in the ocean sector, how we can use all this big data that exists. So this is just a list of just examples of different types of data that exist in the ocean sphere. So we have AIS data. This is data that you'll find for boats, usually satellite related data where boats are being tracked. So there's a cool website you can go and see where shipping containers are going or where they are currently on the ocean. That's always a lot of fun to kind of keep track of. That's the type of data. Text data, we did a data challenge last winter where we were using text data, but not all data needs to be numbers. You can use text as data as well. Another common one is GPS location. So a lot of times this is used for tracking animals. So we tag whales and sharks and fish and see where they're going. Genetics, so a lot of eDNA, which is environmental data, exists, where you can sample water and look at what DNA exists in that water to determine what animals and life is present in that area just through a water sample, not actually having to see the animals. We have acoustic data, which is really popular for listening into the ocean and seeing who's out there listening for things, listening for animals, listening for boats, listening for any loud explosions that are happening underwater. That is another important source. And we have images and videos, which are at DeepSense is a common one that a lot of companies like to use, and it's an easy way. It's a common way that we do computer vision, so that we use AI. And then finally, we have time series data, which is what CIOOS uses primarily. So time series data essentially is you're taking a recording of something at a point in time. So there's usually 2 data points related to that, and that could vary to temperature, to salinity, speed, any essentially numbers along those ways. So data is really important and we all use it in different ways. And so the goal of this challenge is essentially to think about how we can use data, we can specifically use time series data and how we can use that CIOOS data, and you're welcome to use other sources of data along with the CIOOS data, but the goal is to come up with different ways to use this data based on the challenges that we present. So I'll let Shen jump in just to do a little more in-depth review of CIOOS, just a little, we'll go even deeper further on, but just to give you an idea of what exists out there.
Yeah, just a little high level review. So yeah, like I said, we have a national website that basically just stores all of our coastal and ocean data across Canada. So we have a team of staff from Halifax to Vancouver to St. Lawrence region who work with regional data contributors. And then they integrate that data and metadata into our national data catalog, which is accessible regionally, nationally, and internationally. So CIOOS then uses this shared data to create different visualization tools, different applications to help the public understand the data better and to help scientists and academics sort of plan for the future and help us understand the future of Canada's oceans and really benefit Canada's ocean observing community. So in terms of what kind of data CIOOS currently collects, we do provide all support for all physical, chemical, and biological ocean variables aligned with the global ocean observing system. So basically, this just means that all of our data is interoperable with international standards. So if an international organization is curious about something to do with Canada's oceans, then we can point to CIOOS data and all of the standards, all of the methods will be exactly the same. And that's sort of what that means. There you go. That's your quick CIOOS overview. I'll get more into it later.
Thanks, Jen. So you'll see that Ashutosh dropped in the host and panelist chat. So just quick note to host and panelists, if you want to message everyone, you have to make sure you change your messaging to everyone up before you send your message there. But he'll share a link to CIOOS that you can kind of explore. Oh, not everyone can message everyone. All right, just me again, I guess. That's annoying. Good to know. Let's see. It should be everyone. Oh, okay. Now the panelists should be able to message everyone. I feel like now it works. This is one of the Zoom things that I always forget to turn on. There we go. Yay, it works. Okay, so now the challenge. So the overarching challenge of our Ocean Data Challenge, Coast to Coast to Coast, is how can ocean data help us understand Canada's ocean health, ocean economy, and ocean people? So it's pretty broad, and so we like to break it down into different streams to kind of help you choose a stream to go into. Kind of helps kind of forgetting the word, should focus down on one idea. So we do 3 streams. So the first stream is in the water, and basically this is exploring how oceanographic conditions impact the future state of our ocean. So kind of really sciencey, essentially, go digging into looking at the science behind it all. Then we have challenge stream number 2, which is on the water, and this is diving into fisheries management. So potentially looking at ways the data in CIOOS is able to help support fisheries, whether that be aquaculture or fishing out on the open ocean. Take it however you want. And then our final challenge stream is around the water, where find how everyday recreational ocean users are impacted by our changing ocean. I think we forgot a word there. How bad. But basically looking at how you're able to, or how the everyday person, so the surfers, the sailors, those going on the speedboats, how they're using the ocean and how any of the data can help impact them. So to kind of give more context to everything, we have 3 speakers here today. They're gonna each have about 5 minutes to just talk about themselves, their backgrounds, how they're using ocean data, and then we're gonna dive into the panel. So if you have any questions, feel free to drop those in the chat or in our, there's a Q&A option as well, somewhere at the bottom of your screen, hopefully. But our first speaker is Jason Goldsworthy. He is the Executive Director for the Center for Applied Sustainable Technologies, also known as COAST, on the West Coast, with over 20 years of international experience in managing and engineering businesses and projects. Jason brings leadership's technical and commercial aptitude to the team at COAST. His experience spans multiple industries, including renewable energy, urban development, environmental consulting, mining, and commercial infrastructure construction. So he has worked with the large multinational corporations as well as being involved in several startups. He has acted on several corporate boards in both Canada and Australia and holds a PhD in engineering, as well as is a member of the Professional Engineers and Geoscientists of British Columbia. So got some accolades behind you there. We're lucky to have you here and be able to talk to us, kind of giving maybe a blue economy perspective on how we use ocean data. So you're all you got 5 minutes. Ready
Over
to go.
me. Thanks, Lucia. Thank you. And thank you for the opportunity to explain a little bit about COAST today. I don't have to introduce myself. You did a fantastic job. So I won't say any more except that I did move to Canada about 18 years ago. So I now just tell people I'm a Canadian with a really weird accent. But it's great to be amongst a very dedicated group of people pushing this industry and pushing the direction of where we're going. So just a little bit to start with, I'm coming from Victoria in British Columbia, so on Vancouver Island, and this is the lands of the Lekwungen speaking peoples, now known as the Esquimalt and Songhees Nations. I'm going to tell everyone a little bit about COAST first, which, as Lucia mentioned, is the Centre for Ocean Applied Sustainable Technologies, which is a really long acronym. So we're really hoping the word COAST gets off to everyone and we just know known as COAST. And then I'll talk a little bit about what we're seeing on the West Coast here and where I see the data analysis and some of the opportunities going there in data collection and also data assessment. So to start with COAST, COAST is relatively new. About 18 months ago, it was an initiative of an economic development agency based here in Greater Victoria called the South Island Prosperity Partnership. And its real mandate is, it's a British Columbia mandate, but it's really to grow the blue economy in Pacific Canada. So it's really to see sort of a nexus of companies and industry and people all moving in the direction of seeing the growth to take hold of what's potentially going to be a $3 trillion industry by 2030. For those of you who don't know much about the blue economy, I like to think of it in my terminology. I can give you all the UN definitions and all the definitions from Wikipedia and ChatGPT, but the way I like to think about the blue economy is it's a transition from potentially the way we have treated oceans in history. And I like to think of it as being, we're meant to be treating our oceans like one of the greatest assets we have. So assets are something that we have to manage properly. We have to nurture. We've often talked about things in resources terms, and resources are a bad word because they mean we exploit them and we take from them and we keep taking them from them. And we've noticed that in other industries that isn't sustainable. It's not a long-term play. So I like to think the blue economy is finding ways to treat our oceans as assets. And when we start talking about data, one of the most important things is knowing that we need to understand those oceans before we know how to treat them as assets. So COAST is really here to support or drive innovation and collaboration in British Columbia and the British Columbian ecosystem of blue economy. And that's really in 3 different areas. We look at supporting our existing industries. We have a diverse set of industries here, from transportation, marine transportation to aquaculture. And we need those industries to think about transforming and changing the way that they're operating. So with having all these great ideas and technological advancements is great, but we need those industries to adopt those and take on those. So we are really here to help those industries find ways that they can figure out how to bring these new ways of doing things, that using data, using the AI that we've talked about, how do they work and how do they adopt those technologies? We're also here to support our innovators, a bit like COVE in Halifax, and support those startups right from the Ocean Startup Project into ways to find commercial opportunities. Canada's very good at developing IP. We've got some of the best research institutes in the world in the ocean space. What we want to do is make sure that our IP is developed in something that's commercial, make sure that there's an opportunity for a market adoption of that IP. And that comes in through different ways. It comes through helping those new technologies find a footing in the market and also helping them with funding and support. And the third one is if we're moving to this more digital new technology space in an emerging blue economy market, we're also going to need the people and the trades to transfer over as well. So there's a lot of training and upskilling and changing of skills for people to go from some of those more traditional industries into more of the high-tech industry. So we can't do it all at this smaller scale. We're going to have to bring support from other trades and individuals. So that's a little bit about Coast, and I'd encourage people to look at our website and see what we're doing specifically in those areas. But talking about the data in the oceans, because that's the topic for today, what we're seeing out here is there are incredible new ways to collect data. We're getting more data about the oceans every day. There's new uncrewed vessels, there's AUVs and ROVs, there's sensor technology that we've never seen before. We're now using satellite technology to get new information about data from the oceans. So we're getting this. We've got those tools to be able to bring that data in. It's important that we know what we're going to do with that data and how do we use that data for the future. I see it in a few different ways. CIOOS talked about the research scientific, better understanding the oceans. But we also need to think about how our markets and our industries are going to use that data. How are they going to improve their operations towards more decarbonisation? How are we going to use them to better make sure our shipping alignments or shipping routes are more improved? So we always have to think about there's a way at the end on what that data is used for. And I think these hackathons are a great opportunity to see what people's thoughts are in that and open it up to get some different perspectives. Then there's a third area, which is we don't really know what we could do. And that's the hard one is, we're using traditional models and traditional technologies to then assess that data. There's stuff that we don't even know what's coming around the corner next. And that's the really hard one is let's get the data and figure out what we can use it for in the future. So I think there's a few different uses of that data. We have to be careful as well. There is a lot of knowledge in the marine industry. It comes from our Indigenous communities who have incredible knowledge of our oceans. That has to also be merged in with that data as well. We can't just rely on the data as a solid or as a pure number. So I think it's how we blend all those three together to be supporting our industry and our market needs, how we can continue with our research and our scientific discovery and that better understanding the oceans, and then also keeping our minds open about what are the possibilities for the future, what does AI bring to it, and find this perfect balance of using this data in the best way. I'm really excited to be here. I'm looking forward to the discussions and the Q&A, and also seeing the results of this fantastic initiative that this group of people has kicked off. So I don't know if that's my 5 minutes, but I'm going to shut up now and I'm going to hand it over.
Yeah, that was great. Thank you so much. I love how you kind of brought it all together, have different ways we can use that data. Thank you, Jason. Next, we have Kelly, who is up. So we're now focusing it down to a startup that's using data. So Kelly is a founder and CEO of Coastal Carbon. Coastal Carbon is a venture-backed ocean MRV company. They build AI models that make it possible to see underwater from space. The goal is to enable effective climate action in ocean restoration through trustworthy measurement. In her free time, Kelly is an MBA PhD candidate at the University of Waterloo, building the spatio-temporal models of leveraging quantum machine learning that power Coastal Carbon. That's casual. That's just what you do in your free time. I love it. But I'll hand it off to you, Kelly. And I know you said you wanted to share your screen. Oh, no, Emily is sharing your screen. Is that, she has the slides? Okay. She'll get that going and you're welcome to start.
Sure. Thanks, Lucia. That was a great intro. I appreciate it. Not like I wrote it or anything. Yeah, really excited to be here, everyone. Thanks so much for inviting me. I did a lot of hackathons as a young person, especially in my undergrad degree, and I just felt it was so useful to understand not only like what I knew, but also what I could know in the future. So I just think this is a tremendous opportunity for you all to be here, and really happy that you all are here. So Lucia gave a great introduction. I think I'll pull a Jason and not talk too much about myself and talk a little bit about Coastal Carbon. Up here, you'll see our mission and vision. So the mission is, again, to restore our world's oceans and combat climate change profitably. I like to tell this joke, people hate it. Though we call this planet that we live on the Earth, it's mostly water. 70% of our planet is covered by water, and most of that is held by our oceans. Our oceans do a lot more than just hold our water, though. They are very important for climate mitigation. So right now we think that up to a quarter of anthropogenic carbon dioxide emissions, so stuff that humans emit in the atmosphere, is absorbed by our oceans. And kind of like what Jason said, we don't really understand how we can leverage this in a strategic way. So that's something that we're trying to do at Coastal Carbon. So the vision of what we're doing is we're trying to build the engine of truth to power this coastal carbon industry at scale. And what that means for us is doing it remotely, so using satellites so that people can very quickly understand what's going on, and then also being very scientifically rigorous about how we do it. So let's move on to the next slide. This is us. So I'm co-founder and co-CEO at Coastal Carbon. Thomas, my co-founder and co-CEO, is pictured in the first photo there. We work with seaweed farmers as our beachhead market. Folks like Holdfast NL, Michael is there with a seaweed line. We're starting off by measuring how seaweed sequesters carbon from space, and trying to get folks both better at growing seaweed and optimizing their harvests, as well as helping them access carbon credit markets. So on the next slide. Yeah, let's talk a bit about how we use ocean data. So two main things that I think are important to think about in this hackathon are training and then your endpoint inference. So an example of what we do with seaweed is our AI models are using training data. So that's that satellite imagery that we collect, as well as ground truth data like water parameters or the actual biomass, to basically make a prediction about how much seaweed is in a satellite image at any given time. The endpoint inference is where that happens. So basically you take the image of the seaweed and then you say, okay, based on our AI models, what the AI models have learned about how things are correlated, this is the actual amount of biomass. On the next slide. This is an example of that happening. So this is a seaweed farm in BC that we're working on. I don't know how well this is showing up in the slides, but in the first image that you see in the bottom left-hand corner, that's what you would see like just on Google Maps. If you were a seaweed farmer, you're like, I wonder where my seaweed farm is. Not very useful, just kind of black. What we do at Coastal Carbon is we enable you to see underwater. So in that yellow little box there, you can actually see, they're called the buoys that hold up the seaweed farm, and then also the seaweed that's growing underwater on those lines. And that's really helpful for two things. So one is monitoring. So basically looking at the status of your seaweed farm. Is it okay? Are the lines tangled? Has someone driven a boat through it? Looking at that growth rate, so how quickly the seaweed is growing, and then also looking at things like fouling, which means that is the seaweed going bad and being eaten by urchins underwater? The other thing is prediction. So not only can we say like what the seaweed is and how the seaweed is right now, but we can also say in the future or in the past how the seaweed has been. So we can predict things like peak harvest, which means that the max amount of seaweed that you're going to grow before it starts going bad in the water. Productivity, which means that if we look back in time, how seaweed has grown, maybe like 100 years ago, 20 years ago, to see like what is the most productive bay. And then also prospecting to also say like, if I had a lot of seaweed that I wanted to grow in, let's say, St. Mary's Bay, where is the best place to grow that? So on the next slide, this extends out, obviously. So one of the really cool things about AI is that you can generalize your models. So what generalization means basically is that you make a classifier. So you make something that tells you if something is Lucia or Jason. And then you can expand that out to other people. You can tell if it's Shen from CIOOS or if it's Kelly from Coastal Carbon. So that's a really cool ability of the AI model to be broadly applicable. Even though you train it on one specific thing, you can use it for a multitude of other things. So one of the multitude of other things we're doing at Coastal Carbon is looking at kelp forests. So we use the models that we've trained on seaweed farms, and then we look at biomass monitoring of natural seaweed ecosystems. So there's lots of applications for this. One of them is strategic restoration. So looking at, again, like where is the best to focus our efforts to restore where kelp forests maybe used to live, but now don't live because of climate change. Monitoring of marine protected areas. So those are places where folks have said, we're going to be really careful about how we are stewards of these areas. And we want to make sure that our efforts are bearing fruit. And then finally, what's an issue that's very close to my heart is MCDR, so marine carbon dioxide reduction, and measuring how well or how strategically or how much marine CDR we're doing using nature-based solutions. Next slide, please. So that's us. That's us, Coastal Carbon. Our mission again is to restore our world's oceans and combat climate change profitably. I'm really excited that you guys are here. I think it's just such a great investment in yourselves and also in the planet. And feel free to reach out to me on LinkedIn to chat. I would love to chat with any of you. And thanks for having me, Lucia.
Thanks so much, Kelly. That was great. That was a great example of how you can use ocean data. So thank you for sharing. And now we're going to look at other ways of using ocean data with Clark. So Clark is a physical oceanographer with Fisheries and Oceans Canada who uses observations to understand processes in the ocean that mix and transport heat and salt. His methods for obtaining such data ranges from traditional, so samples being taken at sea using ships, to novel using low power autonomous platforms that sample the ocean for weeks to years. As much as his research depends on working directly with data from many different oceanographic instruments and many different types, he's also a developer of several packages for oceanographic analysis for free and open source software, and open source software systems are. So Clark, you're gonna give us a nice example of how you use data in your day-to-day as an oceanographer. Take it away.
Thanks, Lucia. And I have just 2 slides that, at the risk of seeming a little redundant, are basically, I actually forgot I sent you that little write-up. And I made 2 slides that are basically just exactly what you said, but it gives me a chance to talk about it with a few pictures. So I will just share that and put it up. There's not a lot of text on there. It's mostly just pictures. But I thought it would be fun to kind of just step through some examples of some of these different ways that I collect data and the platforms that I use and the reasons why we may need to use some of these platforms over more traditional sampling. So as Lucia said, I'm a physical oceanographer, or as I often refer to myself, because my background is in physics. I'm an ocean physicist. And that what that means really is that my interests in studying the ocean are not exclusively around physical properties, but really focus on the physics of ocean transport processes and how physical processes are changed and moved and mixed. And so that means measuring things like, as Lucia said, temperature, what the temperature of the water is, how much salt is in it, which, to be honest, the real reason we need to know most of those things is because it tells us what the density of the water is. And for those of you who've taken physics, density is the most important dynamical quantity when you're talking about a fluid. So it's important in that regard. And then there's lots of other kind of components of that are interesting, but primarily I spent a lot of time thinking about how to measure currents in the ocean. So how fast is water moving? What direction is it going? Is it going in different directions in different places or at different depths? Are there waves? Are there motions inside the ocean? Because the ocean's not just a uniform temperature and salinity. If you go through the vertical, it changes as you go up and down, and that can actually support motions inside the ocean or waves that you can't see from satellites or even from surface measurements. So this slide just shows kind of an array of different things that I've done and different kinds of technologies I've used. And on the left is actually my PhD work, which I did through Dalhousie University, but most of that, the field work that was involved in that program was making measurements of what we call internal waves, so waves that are inside the ocean in the St. Lawrence estuary. So that's actually the St. Lawrence estuary. You can see on the left there, we're lowering a frame to the bottom of the ocean in about 30 or 40 meters of water to measure basically temperature, salinity, currents of these waves for several weeks, basically. This was a short experiment. We were there for a short amount of time, left these instruments in the water. The next panel over doesn't show any data collection, but it does prove that I was there. I've done some work in Greenland, trying to measure the interaction between the meltwater that's coming off the Greenland ice shelf and the ocean that's right next to it, right? So we have there's a lot of meltwater coming off of Greenland. A lot of that goes directly into the Atlantic Ocean around Greenland, and it's a big mystery as to what we should expect there. Because not only is that water actually cold, which is interesting because a lot of the North Atlantic is relatively warm compared to Greenland. It's very fresh, right? So we're changing both the sort of heat input and salt inputs as we increase those freshwater fluxes. And as an example of some of the technologies, I've got sort of three pictures here. The one right in the middle it's a type of platform that I do a lot of work with, but can't take much credit for because it's actually part of a very large international program. These are referred to as Argo floats, so ARGO, just like the ancient Greek legend of Jason and his Argonauts. And these floats are equipped with sensors, but what's neat about them is that they are able to adjust their buoyancy, so they can move themselves up and down vertically in the water column. And when they do that, they can take measurements and send them back to satellite when they're at the surface. And what's really cool about this program is it's a big international collaboration. There's a lot of different countries involved. Buy these floats, put them into the ocean, let them drift around and collect data. And as of today, there's about 3,900 of these in the global ocean, sending back profiles. Each one sends back a profile every 10 days, which means in 10 days, we get 3,900 profiles from 2,000 meters to the surface from these things. It's an amazing program, huge amount of data in there. It's used for a lot of very important operational and science uses, but it's one of those things that every time I look at the data from this program, I just come up with more ideas of things I could do with it. And related to the Argo floats, down in the bottom corner there is sort of like the fancier older brother of an Argo float. It's what we call an ocean glider. Essentially the same principle. It's a tube with sensors that can control its buoyancy, but with a glider, what it can actually do is, instead of just going up and down vertically, it can tilt onto its side, and it's got some little wings on it, so it can actually drift sideways as it goes. And gliders are like a fancier version of a float in that we can actually, steer them a little bit. They're autonomous systems. They can kind of navigate more or less on their own, but I actually tend to prefer to call them supervised systems because they do still require someone to pilot them and keep track and make sure they're not getting into trouble. And the final example up at the top there is a system that was designed by my colleagues at Fisheries and Oceans Canada and by myself, which is an under ice Arctic observing system that we use with an array of different instruments and an underwater cable and a bunch of technologies like acoustic modems, which it's like underwater telephones. You can send data without having a cable connecting them to get data from the Arctic Ocean year round, basically, even when it's covered by ice, which it is something like 10 months of the year in some of those spots. So the other thing that Lucia mentioned is that let's see if I can change the slide here. I can't for some reason. Don't know why. I'm just going to hit play. Can you still see those slides?
Yep. Yep.
Yep. Okay. So second slide. Yep. And I don't need to harp on this a lot, but I'm a big user of data. I generate a lot of data, which means I have to use a lot of data. And I have found, it just went away for some reason. I have found that, there's a lot of different tools out there for working with data. Sometimes they do what you want and sometimes they don't. And so I've actually spent quite a bit of time over the last decade or so developing scientific software and free and open source tools for working with oceanographic data. And what's up here is just a smorgasbord of a bunch of different things. Some of them are papers that have been published about the software. You can see there's a common theme here. A lot of the work that I do uses the R software for statistical analysis, but it's a great system for working with data. And by data, I mean real data, data that has warts and missing values, and you want to do time series and you want to try and do quality control. And so I do a lot of my work with R, one, because it's free, it's open source, but also because it is really a good data analysis language. I use GitHub for doing a lot of that kind of development. A lot of this is all done out in the open. Users frequently send us bugs and improvements and things. And aside from just general data analysis, I have a few tools that I've written or contributed to for working specifically with the Argo program. So there's a couple of packages there that I've got up on the screen. You can find them by Googling, which allow through R to have access to the full range of Argo data and all of the floats from the full kind of 25-year history of that program. So yeah, that's it for me, I think. I'll stop sharing.
Great. Thank you so much, Clark.
Thank you.
That was a great insight on kind of the ocean physics and data, which a lot of the data that you talked about is similar to what we'd be finding in CIOOS. So if anyone has any questions for our panelists, feel free to either drop them in the chat or you can use the Q&A box if you want to remain anonymous. But we're going to do a quick little panel discussion just to kind of get the thinking juices flowing for everyone. And I can kick things off. So obviously our overarching theme is data. We've all talked about different forms of data, how we're using data. Does anyone want to jump in about any pressing challenges that come to mind that particularly benefit from data-driven initiatives? If there's anything that comes to mind, maybe. Yeah.
I'll jump in there, Lucia. I think pretty much all of our technology developments as we move forward are going to rely very heavily on the data input. I'm just thinking the example Kelly talked about with blue carbon or MCDR technologies. They're all going to need a whole host of new technologies, data capture, data analysis, data assessment to really establish that market. And without that, there's no carbon, there's no MCDR market. So that's a big one that I think as that market gets matured, there's a lot of input for the data. But then when we're talking about building more complex situations, we're talking over here about where does autonomous surface vessels go, and do we go to a point where we have more autonomous vessels? They're going to be incredibly data driven, whether or not it's in terms of what routes they take, what other vessels are on the water, what mammals are around to avoid mammal strikes. So I think anything we look at in terms of the direction we're going in this sector is going to need a huge amount of data captured, assessed, and then evaluated and input into the operation. So I think it's I don't see any one particular area that needs to. I think they all are. And one of the things is they're all complementary. So the data you capture potentially for an MCDR technology, it's going to include surface current, waves. If you're talking ocean alkalinity enhancement, that has to all then be used for autonomous vessels as well. So we can't silo it out and say, okay, this technology needs this data and this technology needs. We just need more and better ways to understand it and share it. So I don't think I specifically answered your question there, except to say everything. Yeah, it's very interdisciplinary. I'd see, like you mentioned in the beginning, how bringing everything together, but even with the data, it's having to bring in the data from using it more than once. Obviously, we're not going to use temperature just for one specific thing. It's going to be used amongst different projects, different initiatives. And I think that's a really important thing, like silos, like making sure that we're eliminating as many silos, because I feel like you get the richest ideas when you have a bunch of interdisciplinary minds coming together and looking and accessing things through different ways. I don't know, does anyone have an example perhaps of where that worked, where you kind of saw a huge difference of when you're looking at data and started working with maybe someone who came in with a different perspective on how to analyze or look at it, or provide some kind of light bulb moment in anyone's work?
I can jump in, Lucia.
Yeah.
So obviously I'm coming at this from an AI angle. And when we were looking at satellite imagery, I think traditionally, so I come from a terrestrial background, I'm actually a land person. We looked really closely at linear models. So those are things that basically, like, you take one thing and you take another thing, you look at the ratio between that. From an AI standpoint, you theoretically learn a richer representation of a system if you have a neural network or a deep learning model, because basically you're able to take more variables or more features and kind of make a map of what you're ultimately trying to model. And I think that paradigm shift of looking at, hey, like, things aren't just like AX plus BY equals Z, to like, oh, can we take a look at like all the data that's out there? see what we can correlate it to, and then see what kind of insights we can draw out of that has been really, really helpful in remote sensing for oceans, but then also just more broadly, I think, for ocean data in general. And I guess my overall thought is that, as Jason mentioned, we are transitioning to a society where we have like this like plethora of data, just so much information that like is really hard for the human mind to grok, right? Like it's almost intractable. Like there's just so much. Being able to develop models or simulations of things that can ingest, so take in all this data and then tell us some very useful things if we ask the right questions. And I think that's the really operative thing, like what questions we ask of those models, I think will really help us to understand our oceans better, and then also maybe help our oceans and restore our oceans as well.
Awesome. Thanks, Kelly. Yeah, it's like too much data, and how do we tackle that and better? Yeah, asking the right questions. You guys said it perfectly. Because there is so much data out there, but it all might not be relevant. Clark, I see you're unmuted. Do you want to add something?
Just one thing I would add, which is a little bit of a counterpoint, but also an example perhaps, is talking about using data for training models, which is the whole basis of building those models. But as someone who collects the data, I'm keenly aware at all times in the process of what the potential uncertainty of that data is, and also what the quality of that data is. And that's something that as a data collector, we're constantly terrified about, right? We need to know that we collected a measurement and that was from a sensor that was working properly in an environment it was designed to work. And that's all to say, like, you need to be really careful, right? Like, you can't just suck in terabytes and terabytes of data and hope to get good answers out of it if that data actually isn't any good. And so I think that's maybe tying it into something like CIOOS a little bit, where there's data, but there's also a lot of metadata around the data you're using. And a lot of that for me usually relates to how that data has been processed and quality controlled. And this is the point I'm leading to now. We're getting into a world where there's so much data that quality control process, at least the first stage of it, almost just can't be done by humans properly anymore. You can't have people sitting through and going through stuff. And so, some of these programs like the Argo program have been looking into ways to use these sort of large data, big data and sort of neural net approaches to finding the common problems that you might expect to see, and using that database of good corrected data that we know we have to actually drive data quality higher going forward. So anyway, that's a bit of it's like a two-edged sword. You need good data to get data, but you need the data to get the good data.
all the different types of data. Yeah, that's really fascinating. And kind of going off of that and like talking, how is there like you get all this data and we analyze it, we find results. Is there as like a sweet spot of like relaying that back to the public, like through data visualizations? Like, how do we get something that's understandable for like a specialist, but also for the lay people, for the general public, but still keeping it scientifically accurate? I feel like there's plenty of examples of misuse of data with COVID, but like, what have you learned anything from like how we can like apply that model to like ocean data and like communicating back to the public potentially?
I can jump in first, Lucia. So something that I think about a lot in our work is like whether data is absolute or if it's probabilistic. So when we make predictions using data, that's not necessarily something that we have, as Clark mentioned, full confidence in. We have a range of confidence on that data. And I think sometimes when you're using especially like big data driven models, we tend to believe that whatever's outputted by these big data models is an absolute truth. So like if you type something into ChatGPT and you're like, is Lucia in Halifax? And it says, no, that's an absolute thing. But like the confidence, like the probability of the correctness really varies. So being able to think critically about whether or not something is probabilistic or absolute is really important. And I think it falls on us as AI practitioners to say, look, this is the thing that my AI model is outputting, but this is how confident I am that that is correct. So that goes back to thinking about like what your accuracy is, what your metrics are that you measure your AI models by, and what benchmarks you look at when you're ultimately evaluating how good what you're doing is.
I think if I can just touch on that as well, and I think it all comes down to, again, what the use of that data is in terms of real world problems, whether or not, you know, we're using one of the organizations out here that's a big data producer, and I think it's part of the data set is Ocean Networks Canada, and they're using it to, they're collecting lots of data, but they're using it to predict potential tsunamis and the tsunami risk. So once you tie it to an actual use, I think you get people to understand that, you know, there's a background to it. So there's definitely the accuracy part of it as well, but we need to find ways to make sure that the data we're collecting on the back end through the scientific community is then translated to something that actually is a real world problem. If we just collect data and just get lots of data, and back to Clark's point, you know, there's inaccuracies in it, there's lots, and it doesn't mean anything. You know, it has to have that real world application. And I think sometimes we lose that from this immediate need to get more information. I think we have to come from the back end a little bit for that real world implementation.
Yeah, definitely. And it kind of reminds me of what you said when you're speaking of like the future, because of course, we don't know what the future will lead. And we don't know, I guess, right now what data we are collecting that will be relevant to those future problems, right? So it's also kind of making sure like, oh, collect as much as you can, but maybe we won't use it right now, but who knows, maybe in however many years, it's going to be really important to know a very specific measurement that we've been collecting for decades. Who knows? I have a question from our audience. What are the limitations of using generated data in your respective fields? Anyone want to jump in on that one?
I can go first again, Lucia.
Okay.
So I'm not sure what the question asker is referring to by generated data. I'm going to take that as like outputs of generative AI.
Do it.
So
run with it.
Sure. Yeah. So at Coastal Carbon, we do use generative AI models. It's kind of like the hot newfangled thing that investors like to hear about, but actually like also it really does drive value to our customers. And one of the big problems of generative AI right now is hallucinations. So basically, if you give a model something, for example, let's say at Coastal Carbon, we're trying to use generative AI to make satellite imagery resolution higher. So if it's like a kilometer resolution, we're trying to take it down to the centimeter resolution, and we're trying to generate that. Sometimes, like most times, it'll give us really good upscaled or high resolution imagery, but once in a while, it'll just hallucinate something completely different. It'll just be like this crazy, like Picasso-esque image of water and ears and eyes and what have you. Which obviously is a problem. That's a real big limitation. So the key thing there, and I think something that is being talked about by regulators now, especially with that Biden-Harris Act that was introduced recently, is putting guardrails on, I think, as like practitioners. So being able to step back and say, hey, what are the ways that this might go wrong? And in generative AI, I think hallucinations is a big one to think about, especially when you're dealing with natural systems, and especially when you're dealing with folks that might use your generative AI outputs. And then saying like, how can we correct for that? So at Coastal Carbon, the way that we correct for hallucinations is we'll look at the difference between like the actual image that we anticipate it'll spit out and the hallucinated image. And if it is hallucinated, then we can look at the pixel values, so like the difference between the two images. So if you're like putting it up to a light, if it's vastly different, then we'll say, hey, actually that was really bad. Let's regenerate that image to make a more accurate one.
Great. Thanks so much, Kelly. I have a question for you, Clark, specifically. You mentioned measuring the underwater ocean current and touched on glacier melting and global warming. The question asker is looking into glacier melting and its relationship to global warming and is wondering if the underwater current is related to this. And if they want to showcase glacier melting, what are some interesting data sets to examine this?
Well, I can't answer this in the 2 minutes that you're probably going to give me, but I can hopefully give you a few tidbits that you could use to Google and maybe find some data sets to use. So, I mean, the short answer is the ocean dynamics in the ocean are complicated. And so, of course, adding freshwater and heat in different places changes the currents because of the way that they're driven by density differences. That's physics. That's Newton's law, F equals ma. So the questions around, how melting Greenland can show up as currents that maybe then affects the way Greenland melts more are really active research programs right now. There's a current program. It's a big international effort, but mostly led by the US, called OSNAP, OSNAP, overturning in the subpolar North Atlantic. This talks about what we call the overturning circulation, which is where water that's made very cold and dense in polar regions actually sinks very deep into the ocean and drives this so-called conveyor belt. So there's a lot of questions around, how adding a lot of fresh water to a system that's done this for millennia might change. And so Argo is one of the greatest tools we have for that, the floats that I was talking about. We also make a lot of directed measurements that are not necessarily always open right away and available. But to connect a little bit to the previous question about generated data, because I think of that a little bit differently. In oceanography, we use models a lot, and I mean models in a broad term, could be statistical models, and AX plus B, but we also use dynamical models. So this is where, rather than throw a bunch of things in a pod and give some correlations and relationships to them, we actually take the equations that describe the system, or that as we understand it. So the full, nonlinear dynamical equations that describe the motion of fluid particles, and we turn that into a computer model. Same thing that weather forecasts use, but we do this on the ocean. And there's several different models now that are being run operationally, much like a weather forecast model, that you can actually just, it's not necessarily easy, but the data is freely available. I don't know if CIOOS actually has connections to some of these models. The Canadian community, Canadian government, through Environment and Climate Change Canada, runs several of these. There's models called REOPS, which is the Regional Ice Ocean Prediction System, which these are available through different portals, and these can be really neat ways to look at some of those questions, because they will put data in places where we haven't actually measured it, just by extending the observations that we have through dynamical relationships. So anyway, that's kind of the short answer. Hopefully that made some sense and gives you some places to go looking.
Awesome. Thank you so much. We are coming to the end of our little Q&A panel. And I had one very important final question. Is it data or is it data? I never know which way to say it. I keep switching between the two. Is there consensus in the community? Are we
tomato,
sticking to one?
tomato?
Tomato, tomato. But does anyone actually say tomato? Is that a thing?
I say
Jason,
tomato.
as an Australian,
When I want to annoy my kids, I do.
What's this tomato stuff?
That's great. All right, so data, whichever you prefer. But thank you everyone for joining. A couple of our mentors, there's going to be a Slack channel. So they are on the Slack channel, and if you have any follow-up questions, you can reach out there. They're welcome to stick around. I know there's some questions in the chat here, specifically for you, Clark. Are models like Redoc available to the public? And you can answer that in the chat. But thank you for taking this time this evening for me, afternoon for you, some of you, and meeting with us. I hope this was helpful for our participants. And panelists, you're welcome to sign off, but everyone else stick around, because we're going to be reviewing the challenge in some more in greater detail to make sure we're all on the same page. But again, Kelly, Clark, and Jason, thank you so much for taking the time with us
Thanks,
today.
Lucia. Thanks, everyone.
Awesome. And so we are going to jump back into our panel discussion, not a panel discussion, sorry, presentation, to ensure that we are on track and not here all night long. So we had some great insights there from our three speakers, Jason, Kelly, and Clark. But now to kind of go into more detail. So I mentioned earlier our 3 challenge streams. And those were kind of light, challenge stream lights on the previous slides, but this is then broken up into a bit more detail. And again, this stuff is going to be available on our website. We're going to be emailing everyone with links to different documents where you can review this in, as well as listed in our Eventbrite. But hopefully they maybe make more sense and have a bit more context now. So we have challenge stream number 1 is oceanographic conditions are rapidly changing across Canada with the creation of national repositories for the ocean observations, such as CIOOS. Access to data and information is becoming easier, but it doesn't allow to evaluate these data point sources. So it's kind of being able to dig into that and explore and see if there's ways that you're able to come up with maybe some ideas of better ways of analyzing that data. And then challenge stream number 2 on the water is oceanographic data can be directly correlated to commercial catches, enabling greater insight into when and where certain fish species are found. This allows for precision fishing, increasing targeted catch species while avoiding bycatch and choke species, and means quotas can be improved. So about 3.5 billion people rely on the ocean for protein and seafood. So aquaculture is a really important industry. So maybe we interested in diving into that one. And our final stream is around the water, which is we all strive for healthy ocean-human interactions. And a goal of CIOOS is for recreational ocean users, from swimmers to kayakers, to use online platform to plan their day on the water. So maybe developing a resource tool or visualization that explores Canada's coasts and oceans, allowing the everyday user to understand the data in a context that supports sustainable use of the ocean. So kind of one of the questions of the panel is, how do we tell this data to the public? So this could be coming up with ways to do that with people, helping people with their marine activities. So we can go down to the data slide. So Shen will go do a deep dive into how we use CIOOS. But one of the rules for our challenge is that your submission must include some form of open source data, in this case CIOOS, and it must be referenced or clearly utilized in your submission. So we have provided a list with some CIOOS suggestions, and you're also welcome to add any of your own data sources in addition to the CIOOS one. So the goal is you have to at least use CIOOS in some capacity in your final idea or presentation, but we then you can use supplementary data to that. It doesn't have to be CIOOS data, but has to be at least some CIOOS involved in that. So that takes us to the rules on the next slide there. So rules, like I said, have to use CIOOS data. Also, have to have your own rights or written permission from the owners of any software being demonstrated in the competition as well. Your submission, we're not expecting you to code a complex algorithm that's going to help solve climate change. Your submission can be as simple as just a single really insightful bar graph, or maybe you will want to use machine learning to build a prediction. Surprise us. Judging is based on the potential for impact, originality, and creativity. So we've had submissions where people have come up with an idea for an app. We're not expecting you to create the app, but if you just have an idea for the app, and who knows where maybe that idea could take you down the road. Maybe you want to take the road like Kelly did and have your own startup based on that. Who knows? You're allowed to work alone if you want to work solo, or you can work on a team of up to 5 members. Don't submit any projects containing any confidential information. This is all open source data. Hopefully that won't happen, but we want to make sure we're not sharing anything that should not be shared. Required to use data from CIOOS and can supplement with other open source data, noting again the source in your final submission. The submissions can be either in English or French. So we'll have bilingual judges who are able to do both. And the video submissions must be a maximum of 3 minutes long and uploaded to either YouTube or Vimeo and set to private. So don't send us a file that we have to download. It's going to be a 3-minute final presentation. It could be you talking, you could have slides, could be however you want to take it, but it's a 3-minute presentation that we can stream either on YouTube or Vimeo. We will not accept videos that have to be downloaded. You also have to be living in Canada with an active Canadian bank account and a part-time or full-time student of a university, college, or CEGEP in Canada. Feel free to reach out to info@deepsense.ca if you have any follow-up questions. Just a quick review of our video submissions. Your idea must be present in a video, 3 minutes max, like I said, uploaded to YouTube. We're going to be sharing a link to a Google form that you're going to be filling out, and that will be your final registration. So in that Google form, it's going to ask you your team members, your team name, a little description of your final idea that you've come up with, and a link to your video, and kind of some questions like what you're studying, what university you go to, or college, or CEGEP as well. And these are all going to be due by end of day on Monday, November 20th, because it's national, Pacific time, end of day. So 11:59 p.m. on Monday, November 20th, you can submit through the registration form. And then the prizes. So there's cash prizes at the end of this. So we have $750 for our first prize, $600 for our second prize. Our top creative design will get $500, then judges' choice is $500. So we have a judges' choice category that really kind of depends on what we're going to get. But like I said, we're going to be judging you on presentation, creativity, and the prototype as well. And then a final quick review of our challenge schedule. So right now, Wednesday, November 1st, it is our kickoff. This is us telling you everything about the challenge. There will be a recording of this that we're going to be sharing with everyone tomorrow as well. And basically, we'll have a Slack channel that you can come join afterwards. If you have any questions about the challenge, you can drop them in there. You can help build teams in there. But our submissions, like I said, are due November 20th. And then our judges will review all the submissions that following week to the 27th, and winners are hopefully going to be announced Monday, November 27th. So that is kind of our final review of the challenge. I'm going to pass it over to Shen and remind her that we have 15 minutes with our interpreter. And so to be as quick as possible, and feel free to drop questions in the chat that we can answer about the challenge. And then remember, we still have a networking session. If you're interested in building out your team, you can hop onto that after the session is done. So Shen, I pass it on to you.
All righty, thanks, Lucia. I'll try to keep it under 10 minutes. All right, can we see my screen? Yes.
Yep, looks good.
Perfect. All right. So this is the CIOOS homepage. If you want to follow along, it's CIOOS.ca. But otherwise, this is what you get when you just pop it up. So at the top here, we have the menu bar, and to access and download and source all of CIOOS data, you're going to want to select data tools. So here's a list of our 3 main national tools. And if you scroll down a little bit to the bottom of the page, we also have links off to all of our regional data tools as well. Each of our regions have their own website. So I encourage you to go check them out, just to even see like different examples of what sort of visualizations you can make with ocean data. But mainly for the bulk of this challenge, I feel like these 3 will be your best friend. So starting with the Data Explorer. So this is basically, it looks a little bit daunting. It is a interactive map-based visualization, basically, where it has all of the different data points that are currently in CIOOS that are supported by this application called ERDAP, which I'll get into in a little bit. So basically, it's pretty self-explanatory. The darker the color, the more data sets there are in that location. You can zoom in a little bit, and it'll give you a little bit more resolution here. And once you zoom into like a certain scale, you notice that there are different colors. So this basically correlates to the type of platform that was used to collect the data. So there's mooring platforms, sorry, I don't know if you could select all that. Anyway, so you can filter by what type of platform. You can also, up here at the top, you have different options for filtering by ocean variable. So if you click on this, you can highlight if you're only interested in currents, if you're only interested in oxygen, for example, you can pick and choose whichever ones you want to show up. In this left-hand column here, this has all of the data sets just in a list. Once you find whatever particular data set that you're most interested in, again, you can filter by contributing organization. You can also filter by time if you're interested in temporal, and you can also filter by depth if you're interested in what's going on in the water column. Anyway, so once you figure out what variable you want, you just click on the associated name in this list, and it will pop up just another window of some more basic information. So you have the title, which ocean variables you can find in the data set. You have your contributing organization, and as well links off to our main data catalog. But what is useful about this particular visualization is that you can actually download directly from this app. So if you go back out here, you can select and highlight whichever data sets you want. And then down here at the bottom is the download button. So just for example, if I wanted these 4 data sets, I select them, I click download, and then you have to put in your email address, and then you'll get a link sent in your email that has a link just in a tabular format of all of the data set that you have highlighted here. All right, so that is the data catalog. Gosh, I feel like I have so many tabs open at the moment. It's hard for me to click around when I'm moving like the zoom window to find like the back button. Anyways, so that is the first main national data tool. The second one is the catalog map. This one looks extremely similar to the Data Explorer, but here all the data is in its raw format. So you also have to select which variables you want to show up. Contrary to the Data Explorer, where all the variables are present, here you need to select which ones you want. So they're separated into physical, biogeochemical, and biological, as well as a couple cross-disciplinary, but these are still emerging variables. The majority of the data within CIOOS is physical data. So you got temperature, salinity, and as you can see, once you start selecting the variables, they will start populating on the map. So if you zoom in, you can sort of see the different points. Obviously, the amount of numbers is associated with the amount of data sets located in that particular location. So if you click on one, this little data set list here on the right just shows you all the data sets located in that particular geographic area. It gets more and more specific the more and more focused you zoom in. So once you find a data set of interest, you can click on whatever one from the menu, and it sort of opens up a little bit more information about it. Similar to the Data Explorer, it will tell you what essential ocean variable is included in the data set, and it gives you a link off to our data catalog. So that is the last thing I'm going to show you. Unfortunately, with this asset map, you can't download directly off of the application. You have to link off to data catalog, which I will show you right now. So the last tool here, this is kind of the one-stop shop for all data, all 2031 data sets that we have across Canada. And this is what it sort of looks like as its homepage. So you can search by keyword if you know specifically a variable that you're most interested in. And you can also click on the icon select below here. It's the same thing. You can also filter by contributing organization, so who provided the data to us. You can also filter by region. So there's the Pacific region, the St. Lawrence region, and the Atlantic region. Those are like the 3 main regions that CIOOS has, and they all have their own websites as well that have only their regional data on it. But to see the full list nationwide, this is the nation, this is where you go. So again, if you want to search like temperature, for example, you'll have all of the temperature data sets all listed here for you. So if you click on one, it will open up this other window, basically just explains a little bit more about the data set, has a bunch of the metadata information, the data resources, the licensing, citations if you're interested in that, any keywords associated with the data sets. But the most important thing, I guess, to highlight here is this data and resources section. So here is going to be different for every data set. So depending on what the data contributor provides, like it could be a link off to an Excel spreadsheet, it could be a link off to an annual report or a scientific report associated with the data kind of thing. But most important application that CIOOS is using is this thing called ERDAP. So if I click on that, I know this looks a little bit scary, but I promise you it's not. So this is basically a tool where you can apply constraints on the data set to isolate variables of interest. So basically this allows you to pick and choose what data you want to download so you don't have to download the whole data file, because a lot of these data sets in CIOOS, especially the ones from Fisheries and Oceans Canada, ones from Ocean Network Canada, they have like thousands and thousands of data sets in them. So this is just an easy way to isolate the data that you want. So you can check or uncheck whatever variables you are most interested in. You can also apply constraints on the data. So for example, here, the variable of air, water, surface temperature, you can say, I only want data that's greater to or equal than like 10 degrees, for example, and it will only put out the data that is below or above or whatever constraint you put on it. The last two columns here are the list of maximum and minimum values associated with each of these variables, so you know already what limitations you have on each end. You can also, can you see my mouse? I feel like I should have asked that before.
Yes, sorry.
Yes, okay. So this generate the URL button, I feel like is going to be very useful for you guys. So basically what this does, you click on it and it generates your own unique URL. So if you have specific variables or constraints on your data and you don't want to go through and redo everything, say you like closed your window for the night, you can use this generated URL data to, generated URL to